the ArcGIS Python API for analysts and data scientists. So since this is a demo theater, I'm going to just be showing you a lot of code, and I'm going to be using the notebook that I had shown at the plenary as an example of what an analyst could do. So while this scenario talks about crime mapping and analysis, the story is really trying to tell us how you could go from your data to your analysis and what tools are available to you. So the scenario runs like this, that there's some data that the police department in Houston provides in form of these Excel files, and we want to get all of this data. So in this case, I know that the URL is in this format. It's this URL followed by the month and the year. And since we are Python developers, we can just write code that for this, for year from 2016 to 2017, and for month 1 to 2. So really, I'm only getting data for 1 month and 1 year, but you could get it for all of your. But to make this simpler and fast, I'm going to just fetch 1 month of data. So I got my data. I'm reading it into this data frame, and I could write it out to a file if I wanted to, although in this case, it's not necessary. So this is what the data frame looks like. I could query it using pandas, just the head of the data. So it contains the date, hour, offense type, beat, premise, and the street type, street name, street type, and suffix. As you see, it has got some hyphens that I want to clean out, and maybe I want to rename some columns. Now, when I really fetched this data for the 10 years, I found that over the years they kept changing the name of their columns, and I had to do a little more cleanup. But the good thing is that now I need to do less cleanup. But as data scientists, you know that a lot of your time is in getting your data and then cleaning it up, and you want to automate that process. So if when new data comes, the same code runs and it cleans up your data. So in this case, let's see what I'm doing to clean up the data. So I'm reading again the file that I had just written out. This could be useful if you're doing this analysis over writing the code, and you don't want to lose the earlier steps. So you save it, and then you come back in your notebook. You could just start running from that cell onwards. You don't need to run, fetch that data file again and again. So by querying the shape, I see there are 10,000 offenses in this data frame and 10 columns of data. I'm dropping the null values, and I'm replacing those hyphens with empty strings. I'm renaming the offenses, the pound offenses column to offenses. And as you noticed, this data has a block range, but I really want to get an address. So I'm getting an address that's the midpoint of this block range. And I'll be using the block range, the street name, and the type, and the suffix to compose an address. And all of these addresses are in the city of Houston. So the code I do, this code is splitting that house, that block range into a house number by getting the mean of the start and the end address. And here I'm composing the address, and that is by concatenating the house number with the suffix and the street name and the type and the city. I'm also getting the hour. I'm cleaning up the hour column. It contains some junk values, and this shows how using pandas I can create new columns. So one of my columns was a date, so I could, using pandas code, which is Python's data analysis library, I can easily get the day of the week, and I believe that for my analysis the day of the week might be useful. I'm renaming the offense type column to a category column. So these are some of the steps that you might do as a data scientist or an analyst, and this is what my cleaned up data frame now looks like. It has the date, hour, day of week, category of crime, number of offenses, the police beat or the administrative division where the crime occurred, and an address. Now I want to write this out because, as another step in this process, I could write it out to a CSV file. Now, I want to geocode this data. It only has the addresses, but I want to get X and Y coordinates. I have two options to do that, and maybe I'll show one and run another. The first option is to use the Geo Coder that comes with your ArcGIS Online org, comes with ArcGIS Online, or is configured with your portal. So here I'm connecting to my portal, and that portal, in the geocoding module, we've got methods like get geocoders and batch geocode. So I'm getting the first geocoder in my GIS, and for its locator properties, I'm getting the maximum batch size. So when I call batch geocode, there's a limit of addresses that I can send in one batch. So I'm querying the batch size, and I'm querying the length of my data frame. So I'll just okay, okay, so my batch size is 1000, and the number of rows in my data frame is 10,000. Now I'll need to chunk up the addresses, the 10,000 addresses, into 1,000, chunks of 1,000 addresses each while calling batch geocode. See, this is the line here that's really geocoding all the addresses. The rest of the code is to chunk it up into sizes of 1,000 each. And then when I get back the results, I am querying the location property from those results, getting the X and Y, and creating a geometry. Now, the reason I'm creating a geometry is that down the line I'll be creating a spatial data frame, and that requires these geometries. Now you'll notice that I'm using ArcPy geometries here. The spatial data frame is actually an upcoming feature of the API that's not already released. And since it's in development, we have it prototyped with ArcPy geometries, but eventually it's going to work with ArcGIS geometries. And I ran this geocoding earlier today, this morning, and this is, it stepped through and created those. But there's another way you could geocode your addresses, and that's slightly more performant. And that's using the newly released parallelized geocoding tools. So the way those geocoding tools exist as a geoprocessing service. So while I'm showing you how to use the geocoding tools, you're also learning how I could use any geoprocessing service. Okay, so this is, I added my file to my portal. The way the geocoding tools work is you have to first add a CSV file to your portal, then you tell the geocoder to geocode that CSV file, and it writes the results to another CSV file that you can download. So I've written my CSV file, and well, I had, okay, so Houston process, let me query that, what that was. Insert cell above. So that's the one I just created, the Houston process demo.csv. I just added that. So this file, I'll rename it. So because I added it, I could search back for it. That's the same item that goes as an input to the geocoding tools. How do you get your geoprocessing tools? You could search, just like items, web layers and web maps. Tools are also published to your GIS, and you can search for them by specifying their name, and you could also give a type, like in the case of tools, the type would be geoprocessing toolbox. So what you're really getting is a geoprocessing toolbox. How do you use a toolbox from the Python API? You can call from ArcGIS geoprocessing module, we've got a method called import toolbox that lets you pass in a toolbox and imports it as a module. Now, this is a module that's been, it's like any other Python module, but it's been created in memory and it's created dynamically. So I see that in that module, I see functions like analyze geocode input and batch geocode. These are what I'll be calling. And what's great about using this, geoprocessing tools is when you import a module, it creates these functions, and it also creates the help for those functions that you can read about. Like the analyze geocode input takes in as parameter the geocode service URL, the input table, which is what I had published, the file name, the column names, and so on. So you know what parameters it takes and what it returns. It returns so the analyze tools first looks at that CSV file and creates some parameters that the batch geocoding then uses. So here I'm calling analyze, and it results in geocode parameters that I then pass into batch geocode as a parameter. And it's going to my portal and batch geocoding those addresses now. So I've told it to batch geocode the addresses in the Houston item object that I just uploaded. And it's batch geocoding them, 63% done. Let's, we should be done soon. And it's a lot faster and does not use credits. So it's, if you're using ArcGIS Online, you would be consuming credits. This one, you've already licensed it in, so it's in your organization, in your on-premises portal. So one mistake I did was I reran it with this same output, file name, so it could not override it. So you get your, if you run into errors, they show up in that pink code, and you can rerun that cell. So I fixed my input, and now I'm geocoding those again, and they should be created in a new CSV file with this name, Houston Geocoded Demo. It'll give me the results in this geocode results object, and I could query the item ID from that, and using that item ID, I can use my portal.content.get to get that item. So geocode crime is the item, and then I can actually download that CSV file. So I'm querying that, and on my file system here, I got the geocoded output. So I'm going to read that as a data frame and query it, and I see it has all those columns, and in addition, the geocoder has put the X and Y column. Now I'm again creating those geometries because the next step is going to need them. I'm cycling through all the rows in that data frame and creating geometry point objects and adding them to this geometry guy. Here I'm showing how I can use the spatial data frame. Spatial data frame is an upcoming capability of the Python API that lets you work with spatial data, feature classes as if it were a pandas data frame. So the way it works is you pass in a pandas data frame and you pass in the geometries that go with each row. So in addition to my pandas data frame, I also got a shape. And this will give me the ability to do geospatial operations like geometry operations, selection by shape, and querying by shape, in addition to querying by attributes. It's a very powerful capability that we'll be adding soon. And here I'm specifying that this is the spatial reference of that data. Now, once I have that spatial data frame, I can export it out to Geo database, or I could export it out to shape files. Once I've exported it out to shape files, I can actually zip it up. So I'm going to zip up the shape file, and okay, I'll create a new folder where I'll zip it up. So it shouldn't be the Houston folder. I'll create a new folder named Houston 2. Well, actually, I put all the shape files in here, right? So let me delete the ones I had run earlier. So it only contains what I just exported. And this is the code that's going to zip up the shape files. And the reason why I'm zipping up the shape files is that in the next step, I want to add that shape file to my portal. So now my data preparation is complete. I've got some geospatial data in shape files or file geodatabases. In some cases, you might already have that data and you want to start from this process. How do you connect the data to your GIS? So I'm moving to that portion now. So I'm connecting to my GIS, which is this portal here, and I'm adding this shape file that I just created as content to my portal. And I can call item.publish to publish that as a feature layer. So since the name of this feature layer was Houston Demo 2, I could then, once it's published as a feature layer, I could query my GIS content for that feature layer, and this layer gets returned. It's Houston Demo 2. I could share it out so it becomes a public item. More people in my organization or across the web can start using it. Now I'll be using a lot of maps, and they'll be for the Houston area. So I've geocoded the location and kept it in this variable that I'll be passing into gis.map. Now I'm ready to visualize the layer that I just added as a map. So I created a map widget for use within the notebook, and that's using gis.map, and gave it a zoom level, told it to use the gray base map, and I added this layer. Now note that I can also specify renderers. I can say that it should use the heat map renderer. I can use smart mapping for this visualization. If I didn't pass that in, it would have just given me the point data sets, and in some cases the points are overlapping. They don't tell you the full story, or there are too many points to work with, and the map widget has limitations like to draw more than 2000 or some number of points. So you could use smart mapping for your visualization. And now let's get into exploratory data analysis. And as analysts, you want to first have a look at your data, get a sense of that data. And since I already have my spatial data frame, I don't need to read that in. I skipped running that cell. I got that SPDF in a data frame object, and I'm using maptplolib. This is a charting library provided by, it's for Python, and it has the ability to plot charts. So I'm grouping the crimes by category and sorting them. I'm getting the count in those groups, and I'm plotting the count. So for the month of January 2016, theft was the most common crime. I could group them by day of the week and find patterns like, in that data set, what was the distribution of murders like? And we see that Mondays and Fridays were pretty bad days to go out. Or we could do the distribution by hour of the day and do it for different crimes. So now you've got a sense of that data. You could be using that for your analysis. You get some ideas. Oh, I could perform this kind of analysis. This is the kind of pattern I'm seeing. That's exploratory data analysis. Now let's get into some GIS analysis. And for this, I'm using Geo Analytics. As you know, Geo Analytics lets you work with big data. In my case, I've actually added that big data. And this is, when I generated the shape file, I had put it in a file share where my Geo Analytics server could see it, and I registered it with Geo Analytics as a big data file share. When I did that, the items start showing up in my portal. I can search for big data file shares. So I see that in my portal, I've got two data sets, one distributed by the year and one the combined data set. So I'm going to work with the first data set, which is all of the crime, and find hotspots. So how do you call Geo Analytics tools? The Geo Analytics tools are in the ArcGIS Geo Analytics module that has sub-modules, and you'll find the same division as you find in the home app when you click on the analysis button. So you've got analyze patterns, summarize data, manage data. So all the skills that you learn from the home app, from the user interface, you can transfer a lot of those skills to the Python API. It learns a lot of things from what the home app does, or the home page does. So this tool, the way you call a tool, you just import it, and I'm passing in the crime data set, telling it to, the bin size for half a mile, and a neighborhood distance, that these are parameters for finding the hotspots. So it went out to my data portal, Geo Analytics servers, distributed out the task to several machines, and it got back the results in the form of a layer. So this layer, I can visualize it by adding it to a map. So I'm creating a map and adding that layer. So we got back our hotspots. So the statistically significant clusters of crime are in this red areas, and this is very useful information that can be used to allocate resources. You can also use feature layers that are published in your portal. So in your portal, you might have different layers. In this case, I have a layer of police beats in Houston, and I want to do some analysis. I want to aggregate my crime points into those polygons, those police beats. And here I'm using the summarize data tool and calling the aggregate points. So this is going to take the crime points and aggregate them by the police beats. And that's some information that maybe an administrator might want to know, like, are we adequately staffed? Do we, what's the distribution of crimes like in the different police beats? So you can call different analytics tools, but here the point I'm trying to show is that you can also pass in feature layers that have been published to your portal. So this is running, and in case of some warnings, you start seeing them in the pink color. Looks like it completed. When a cell is running, this circle at the top corner, it's filled, it's solid, and the prompt here becomes an asterisk. So it became empty again, and so I know it's run. And here I'm adding the aggregated layer now, where I've aggregated the crimes by the police beats, and I'm using the classed color renderer. I'm using smart mapping again to visualize it. I could also then look at the data behind the layer. The layer is not just a pretty picture, it has data behind it. So I want to see how many offenses there are in each police beat and sort that. And I know that in this beat there are the most number of offenses. So if you're from Houston, you would know that what that neighborhood is. I could then use plotting. I could do the histogram. Now let's get into some part that I didn't show at the plenary, and I just mentioned it, that you could combine ArcGIS, you could combine all the tools and the data that we have with machine learning or data science libraries. Maybe you want to learn from this data and be able to predict patterns of crime. So this is showing how you could do that. And what I'm trying to do here is, given the historical data set, I want to learn from that data set and see if I can predict that given a time, given a police beat, given a day of the week and a location, what's the most likely crime to occur at that time. And when you're doing machine learning, you might say that, oh, it's not just these police beats that are playing a role here. Maybe it's something to do with that area. Maybe it's something to do with the population index or the average income or the unemployment index. Maybe it's got something to do with demographics of that area. So here I'm calling enrich data tool. We provide data enrichment, and I'm telling it that for all police beats, get demographic data, the key US facts. And I'm getting all of that demographic data, and I'll be using that for enriching my data set. So I'm merging my enrich data set with my original data frame, which has those columns about the time, the day of week, and that location. So now I've got many features. So now when I'm talking about features, I'm telling features in terms of machine learning. You're doing feature enrichment. So these are features for your prediction. And now here I'm using Python as a great library of machine learning tools in the scikit-learn library. So I'm using I tried with Bernoulli, naive bias, I tried with logistic regression, but I'll be using support vector classifier in my analysis. And here I'm doing some some preparatory work that I need to do before I can call the machine learning libraries. I need to create dummies for certain variables, so because this data is not to be treated as a numerical value, but to be treated as a categorical value. So I got my data, and I'm also creating a column named whether it's a violent crime or not. And maybe that's what I want to predict. So I've got my data, and I'm splitting that data into training and validation data sets. So 75% of my data set is going to be used for training, 25% for validation. That got done. I get my features, and I'm training the support vector classifier on that data, on the training data. It got trained, and I'm now scoring it. Like, what's the accuracy that I get with the parameters when I trained on it? I get an accuracy which is actually pretty good. I get a 91.69% accuracy in training this data, in predicting whether the crime is going to be violent or not. I could test that data using the data that I split out, like the validation data set. I do that here, and I get 91.61% validation. So this is basically, showing that you can do this kind of analysis. There's a rich set of libraries available at your disposal as data scientists. And the complete workflow is really in this notebook. I could give this notebook to you. You can run it. That's a great thing about notebooks. It's reproducible research. You don't have to trust what I'm saying. You just run this, and you change. You think something else is important, you use this, or you think you want to run it on your data, or different data, different city, different crime data. You could do that. You want to work on not crime, but some your area of focus. You could learn from this this notebook and apply it. And I think we have like 1 minute left, so I'll leave that for questions. And of course, we can go over to the island, and then we could continue the questions there. Yes. Thank you. Yeah, so the question is, can you import ArcPy in Jupyter Notebook? And conversely, can you import the ArcGIS Python API in ArcGIS Pro? Yes, in fact, in this notebook, if you see in the top right, I'm using the Conda environment named ArcGIS Pro Py 3. So what I've done is, in the Conda environment, I went to Start menu, ArcGIS Python command prompt. That's the Conda for ArcGIS Pro. And in there, I did conda install -c Esri ArcGIS to get the ArcGIS Python library. So from that environment, I'm running Jupyter Notebook as well. I installed Jupyter Notebook, and additionally, I could do all of this within the Python window inside of ArcGIS Pro if I wanted to. Okay. Any other questions? Yes? I'm sorry, can you speak up, please? Yeah. Okay, so the question is, with big data, with what size of data would you use Geo Analytics? There's no lower limit, and I don't know the upper limit. I think the Geo Analytics folks will be, but it's big data, and people are working with huge data sets, and I believe that's got it's distributed. So really, I would assume that it lets you scale up that that size of data. But I'll get you the answer. We'll walk over to the Geo Analytics island, and these guys will be able to tell the precise answer. I don't want to give you wrong answers. Any other questions? All right, thank you so much. Thank you.